Hello teacher, my name is Đào Thị Phương Thảo. I come from Physics K66. My student code is 665113020. Today I will present my presentation, which name is Total Internal Reflection. For the learning goals, in this lesson, students will find out the definition and the conditions that the total internal reflection occurs. About the skills, by verifying the phenomenon of total internal reflection, students will determine the definition and the conditions to have total internal reflection phenomenon, and students will observe and measure variables. About my teaching strategies, first I will check out the previous lessons, the reflection phenomenon, and the content of Snell law. After that, I will read the student the example or problem which have issues that relate to the content of today's lesson. After giving the example, I will ask students to do with me the experiment to investigate the phenomenon and determine the definition and the condition that the total internal reflection occurs. After doing experiment and have the experiment result, students will be asked to state the conclusion that total internal reflection occurs. The key phase of the learning with experiment will be separated into three phases. The first phase is elicit the problem. In this phase, I will check out the previous lesson, reflection phenomenon, and the content of Snell law. After that, I will read students the problem which have issues that relate to the reflection phenomenon of today's lesson. And after giving the problem, I will ask the student to solve the problem and ask student for some possible explanation or prediction for this result of the problem. In this way, students are expected to express the issue after teacher gives the example. And the students use the Snell law and find themselves trying to take the inverse side of a number greater than 1, which is impossible. This is the issue, the problem I give. After that, students are expected to express the function of apparatus and do experiments and record the data. After all, students can make their own prediction. The second phase is problem solving with experiment. In this phase, I will give problem. I will state the problem. How does the total internal reflection phenomenon look like, and in which conditions this phenomenon happens? After giving the problem, I will ask students what quantities should be observed and measured, and how to observe or measure these quantities. After that, I will introduce the apparatus. In this phase, students will have to know the aim of the experiment, the definition and the condition that the total internal reflection occurs. They have to know the experiment setup too, and they are asking to do experiment in two different cases to make the conclusion. can see that if incident angle is, we have learned that when the light goes from one medium to another or through a medium varying density, it's being deflected at the interface between two mediums. But there are situations where it doesn't work. Now we go to learn about this interesting phenomenon. Let's consider a light beam go from a semiconductor glass to the air. We know that the optical density of glass is higher than the optical density of the air, or N1 is larger than N2. In this case, we have the refracted angle is greater than incident angle, or R is larger than I. We can see the phenomenon by watching this video. In this video, we can see that the refracted angle R is increased due to the increase of the incident angle I, and R always greater than I. You can see that. And when R reaches to the maximum value, that is equal to 90 degrees, the incident angle I reaches to a certain limiting angle, called the critical angle. We can come back for about 30 seconds. We can see that if the incident angle is smaller than critical angle, the light beam is separated into two parts, like this. One being reflected, and when another being reflected into the second medium. This is the first medium, and this is the second medium. We can see that this is the critical angle, IC. And let's continue to see what happens if the incident angle is larger than the critical angle. As we can see, if the incident angle is greater than the critical angle, the total light beam will be reflected. The light beam will be total reflected. And this phenomenon is called the total internal reflection, like this. And we can state that when light ray in a medium of higher index of reflection approach the other medium at an angle of incidence greater than the critical angle, the total internal reflection occurs, like this. And as we can see, in the total internal reflection, the total light will be reflected, and there is no refracted ray. In the reverse case, when the light ray goes from the medium having lower index of reflection to another medium, if we increase the incident angle I, the reflected angle R will increase too, and R always smaller than I. When I reaches to the maximum value is equal 90 degrees, R reaches to the maximum value too, and it equal to critical angle IC. So in this situation, it means when we beam the light from the medium having the lower index of reflection to another medium, we always have refracted ray in the second medium. That means the total internal reflection doesn't happen. This is my experiment result for the first case when I beam the light from the medium having higher index of refraction into the other medium. And in my experiment, the total internal reflection start occur at I equal to IC equal to 42 degrees. You can see that from I equal to 42 degrees, there is no refracted angle. And the final phase is conclusion. In this way, teacher will ask students to make conclusion and state the condition of total internal reflection. And from the result of experiment, students will have the conclusion. When the light ray in a medium of higher reflection index approach the other medium at an angle of incidence greater than the critical angle, the total initial reflection occurs. In this situation, all light rays will be reflected and there is no refraction occur. This is all my presentation. Thank you for watching and listening.